Hello everybody, welcome to Dr.K.Liu Math channel. This question is from CU exam question. Tomorrow, not tomorrow. Today is Friday. Yes, Friday. They have to take this exam, and therefore, they asked me this question. And actually, they asked several of this question of this paper, and I hope I can present as many as possible so that they get more advice in the exam. Okay, the first one, define a two-part function fx equal to sine x over x all square when x is not equal to 0 and equal to 1 when x is equal to 0, and find the derivative of f pi x. Okay, for x not equal to 0, we actually only need to direct differentiate this function. Okay, I think I use chain rule to do this function. F pi x equal to 2 times sine x over x. And also, this one is equal to x times cosine x minus sine x over x squared. And this is equal to 2x over x cubed sine x 2 times x 2 sine x times x times cosine x minus sine x. Yeah. Okay, for x equal to 0, we have to use first principle to finish this one. That it means we have to calculate this one. This one is equal to limit x log x h tend to 0 f h minus f 0 over h. That is by definition of the first principle. Yeah. And this is sine h over h all square minus 1 because f1 is equal to f0 is equal to 1. Yeah. And then make a common denominator here. I think we have to use the L'Hospital's rule to finish this task. Yes, the first one, limit by the L'Hospital's rule 3h squared, and this is 2 sine h cosine h. Oh, not 2. This is h squared. And change the format. Sine 2h minus 2h over 3h. And also this is in determined format because the format is 0 over 0. Again, we use L'Hospital's rule. 6h. The numerator is 2 cosine h minus 2. Again, yeah. Let me see. Yeah. But L'Hospital's again. Oh, so many steps of L'Hospital's rule. 4 sine h negative. Then take limit square. Take limit. This is 0. Yeah. Finish the part A. Then for part B. So crazy. It is. It is a lot easy question. Okay, and prove the first that the first derivative of fx is positive. That means first this to prove this is positive, and I let gx equal to this one, and differentiate this one. That is f pi x minus plus cosine plus sine x, and put that f pi x into this one. in this case is for only for x not equal to 0. Okay, but anyway, I think at first I proved the for f pi 0. Then I first write down the case of f pi 0. G pi 0. G pi 0 f pi 0 minus plus psi 0. F pi is equal to, yes. Oh, sorry, no need to do that. Sorry, because the domain that not included the point of 0. Yeah, we only to we only need to finish the task for x not equal to 0. Okay, make a common denominator here, x cubed, and factorize that sine x outside, 2x cosine x minus 2 sine x plus x cubed. Then because this one is positive, has for all x belongs to 0 and pi, this part x cubed is positive. Therefore, I only have to consider this part. I have to see this part is positive or not. Therefore, I here consider x equal to 2x cosine x minus 2 sine x plus x cubed for all x belong to 0 and pi. And differentiate this one. Differentiate this one, I got the answer is 2 cosine x minus 2 cosine x plus not plus minus 2. Let me see. Yeah, 2 sine x. And then plus 3 times x squared. And these two cancel. And factorize the x outside the denominator. And that is x 3x minus 2 sine x. And I think here I used a fact, and that is y equal to x. That is y equal to x. And that is sine x. X is greater than sine x for all x belongs to 0 and pi. And here I only change to something, 3x minus, that is greater than 3 times sine x, and factorize the 3 outside, x minus sine x, that is greater than 0. Therefore, h pi x is greater than 0 for all x belongs to 0 and pi. That is, this h is increasing function on the domain 0 and pi, 0 to pi. And it means that the function h is increasing. Then the least value is h0, that is hx is greater than h0 for all x belong to 0 and pi. Let me see the value of h0. h0, 2 times 0, this 0, this 0, this 0. That is, we have a conclusion, hx is greater than 0 for all x belong to 0 and pi. That is this function. This function is always positive. is always positive. Yeah, that is positive. Let's go back to the original function. That is g pi. That is positive. That is positive. That means g pi is positive for all x belong to 0 and pi. That means the derivative, the first derivative of fx is positive. Is positive. Okay, then next step, we have to prove fx greater than psi x for all x. Okay, actually, that's b pi and c pi are connected. Let me show you. G pi x equal to f pi x plus psi x is positive for all x belong to 0 and pi. That means gx is increasing on x belong to 0 and pi. That means that gx, the least value of gx is 0. That means gx is greater than g0 for x belongs to 0 and pi. And let me see, gx is this one, fx minus cosine x greater than g0 means f0 minus cosine 0. f0 is 1, cosine 0 is 1, that is 0. That means this function f minus g is greater than 0. That we prove fx is greater than cosine x for x belong to 0 and pi. But the question requires to prove x is belong to negative pi to pi. That is all positive or greater than or equal to 0. Then now I prove f0. f0 is actually equal to 1, equal to cosine 0, and f pi equal to f pi equal to 0. Yes. Cosine pi equal to cosine pi equal to -1. Then we can see that fx greater than or equal to cosine x for x belongs to, that is closed interval 0 to pi. Next step, you can see that gx equal to fx minus cosine x. We want to prove gx is even function. That is negative g negative x equal to f negative x cosine negative x. F negative x sine negative x over negative x all square minus cosine negative x is equal to cosine x, and that is sine x over x all square. Oh, so crazy, that is equal to gx. That means gx is even function. Even function means if the positive part is that is 0 to pi is positive, then of course the negative are also positive. That is, we can conclude that fgx is greater than or equal to 0 for all x belong to negative pi to pi. Combine those things, that means fx minus gx minus cosine x is greater than or equal to 0 for all x belong to negative pi to pi. So guys, I finished the proof. I hope guys can enjoy this video, and if you found Dr.K.Liu Math channel is useful, please subscribe my channel.